Hey, good afternoon. It's Chris Potter. It's May 18th, 2017. Sharing with you an article from space.com. It's actually an infographic. I'll put the link below. Titled Brown Dwarfs, Strange Failed Stars of the Universe Explained, written by Carl Tate. He's an infographics artist. This is actually dated material, so it's January 29th, 2014, but I find that it's very relevant. Mysterious failed stars, brown dwarf objects. The brown dwarf pair Lumen 16 lies only 6.6 light years from Earth. Brown dwarfs started out the same as ordinary stars, collapsing from giant nebulas of dust and gas. Most brown dwarfs are not quite massive enough to sustain a nuclear fusion reaction at their cores. Brown dwarfs, therefore, are transitional objects standing between stars and giant gas planets. Not quite stellar. The mass of a brown dwarf can range from 13 to 90 times the mass of the planet Jupiter, or up to about a tenth the mass of the Sun. So here's the Sun. Here's an M-class cool star. Here's a couple brown dwarf goos, and there is Jupiter. Look at this, man. This was crazy. So for folks that don't believe that we probably have one or two here in the solar system, you might be wrong. Because just doing a simple survey of the sky, they were able to find quite a few. Brown dwarfs may be as common as stars. In this map of the Sun's neighborhood, red circles indicate brown dwarfs. No. Know your dwarfs. I like this because I was trying to find a breakdown of all the different types, and I got into a huge debacle of star classification, brown dwarf classifications, old stuff, new stuff, irrelevant stuff, outdated stuff. So we'll just use this article for now and keep it basic. I think this is exciting research because it's not a planet, it's not a star, he's in between, right? And they're dark. It just seems to fit all of the Hercolubus, Nibiru, Planet X, Marshall Masters, John Moore, Bob Fletcher stories. Eerily. Just saying. Okay, so brown dwarfs are classified according to the spectrum of light detected from them. Interesting. Now, I didn't know that. Makes sense, though, right? We're learning together, you guys. I know I'm not perfect. I know I'm probably wrong about 90% of everything I'm putting out. But that's okay, because I'm willing to figure it out myself, correct it, and put it back out corrected. I don't need the trolls to correct me. That's the last people I'm going to go to for information of any kind, believe me. M-class stars are the coolest stars that can burn successfully and are the most common stars in the universe, about 75% of the stars in the Sun's neighborhood. Many M stars are red dwarfs, but some are brown dwarfs. And L-class brown dwarfs are cooler than M stars. Some L stars can produce hydrogen fusion, but most do not. T-class brown dwarfs have surface temperatures in the range of 800 to 1,880 degrees Fahrenheit, which is equivalent to 430 to 1,030 degrees Celsius. T dwarfs are largely composed of methane. Whoa. Okay, so Y-class brown dwarfs are the coolest of the dwarfs. Yeah, the coolest. The temperature may be as low as that of a household oven. Or even the temperature of the human body. What? That's kind of weird. Okay, almost a solar system. And mapping it. I like these little infographics, actually. Then we'll be looking for some more of this kind of stuff. Folks kind of like the whole brown dwarf thingy on my channel. And I'm learning, like I said, I don't know, right? Learning it together. I think you guys are interested in the material. If you are, great. I'm trying to back up on the picture videos because folks aren't sending me anything. Nothing. I mean, so I don't have any data to share. Seems like these articles are more relevant, and I find that I have more traffic on my physicist documents too, so we'll see. So on the left, almost a solar system. Some brown dwarfs are orbited by planets and sometimes disks of matter, similar to those in developing solar systems, artist rendering inset. Astronomers have found microscopic particles of the mineral olivine orbiting in the dust disk. Olivine crystals are thought to be the initial stage of the process that builds rocky planets. Pardon me, rocky planets such as Earth. So the credit here is from European Southern Observatory and JPL on the inset. I figured I would at least mention that because I'm trying to give credit to everyone that's put the material together in this article for obvious reasons. Mapping a dwarf. In 2014, astronomers were able to map features in the atmosphere of a T-class brown dwarf Lumen 168. The clouds are believed to be droplets of molten iron and minerals floating in an atmosphere of hydrogen at 2,000 degrees Fahrenheit, 1,100 degrees Celsius. Credit goes to Max Planck Institute. This is from Carl Tate, space.com. So not quite massive enough to ignite nuclear fusion, brown dwarfs may be as common as regular stars in the universe. That's what this particular infographic is about. We're almost done. Brown dwarfs started out as the same as ordinary stars, collapsing from giant nebulas of dust and gas. Most brown dwarfs are not quite massive enough to sustain a nuclear fusion reaction at their core. Brown dwarfs, therefore, are transitional objects, standing between stars and gas giant planets. The mass of a brown dwarf can range from 13 to 90 times the mass of the planet Jupiter, or about up to the 10th the mass of our sun. Brown dwarfs are classified according to the spectrum of light detected for them. M-class stars are the coolest stars that can burn successfully and are the most common stars in the universe. 75%, right, of the stars in our sun's neighborhood. Many M stars are red dwarfs, but some are brown dwarfs. Again, L-class brown dwarfs are cooler than M stars. Some L stars can support hydrogen fusion, but most do not. T-class brown dwarfs have surface temperatures in the range of 800 to 1,880 degrees, just like I read above. You don't need to read this stuff, dude, because this is just all a repeat. So, all right. Thank you for watching. I'll put the link below. Take care. Thank you for subscribing, and have a wonderful day.